Okay, hello. Thank you, Whitney. Um, I am Mark Fisher. I'm a principal engineer at VMware, and I'm currently working on the Tanzu application platform, and I'll be talking about application platforms today. Um, First, just a little bit of background. My experience with the Spring team started in 2006. I was part of Spring Source back when it was originally called Interface 21, and then acquired by VMware in 2009. In those early days of Spring, I was mostly focused on integration and messaging, started the Spring integration project, did some work on the core framework as well around the annotation support when we first added the auto wiring support and the component scanning support. And then I was also involved in several Spring Cloud projects, Spring Cloud Stream and Spring Cloud Dataflow in particular. And when we were basically all of the Spring team was spun out with Pivotal, at Pivotal, I started focusing more and more on the platform side of things. So we had Cloud Foundry also with us at Pivotal, of course, and we were working on the Spring experience for Cloud Foundry. But I was also involved in something called Pivotal Function Service, which was a serverless experience on Kubernetes. And with that, we basically started collaborating with the Knative team as that project started at Google in the early days. And interestingly enough, all of that came together again when we were reacquired by VMware a few years back. And so I've been working on, like I said, the Tanzu application platform, which kind of takes those ideas to the next level. And today we're going to talk about what an application platform should do for developers. The flip side of this, of course, is what should a platform team be doing to support those application teams that use the platform. And if we go back a little bit for historical context here and think about the way things were, a decade or more ago, it was pretty common that you would have a lot of point-to-point interactions with your IT operations team. You would probably be given a specific server where you would run your application. So we were treating servers as pets at the time. You might have been deploying to bare metal. Virtualization was happening, right? So, being able to increase the resource utilization on those servers by packing multiple VMs was a great benefit from the utilization perspective, but it also created a new trend, which was being able to use APIs to manage the infrastructure, right? And it started with servers and it continued from there to software-defined networking, software-defined policies, and so on. It's really this idea that APIs provide a self-service experience for the application teams to make use of that infrastructure that gave rise to the DevOps movement, right? And the DevOps movement basically applied development principles to managing infrastructure. Because now that everything's an API, you can define the infrastructure as code. And if you can define the infrastructure as code, you can use development practices like continuous delivery for your infrastructure itself. And so what happened in some ways is this shifted the balance to some degree. In a lot of cases, development teams ended up doing more of the operations themselves, right? And this idea of no longer just throwing your code over the wall is a good idea. But as we'll see as we walk through some of these examples, the amount of work that's required to manage the infrastructure in addition to building the applications is a lot for application teams, and no one can really be expected to do all of those things. So as we moved from this IT operations world with DevOps, eventually we've landed at what everyone's talking about today, which is platform engineering. And to some extent, there's a lot of hype out there. There's a lot of controversy around, is DevOps dead and platform engineering is the future? The way I look at this, platform engineering is really just the next logical step on this progression, sort of the pendulum swinging back to a balanced state to some extent, so that developers aren't just doing all the operations themselves and cutting corners where they might because they want to build their applications, right? Instead, the emphasis, I think, with platform engineering, if done right, should be on collaboration. There are many different roles, many different personas in an organization, and they each have their areas of expertise. And if done right, a platform allows each of those members to bring their expertise, to focus on their area of expertise, and not have to do all the rest of it, right? And it all comes together in the platform. So obviously the platform engineer is involved in that. They're the ones who actually manage and maintain the platform as a whole, but they may take contributions from network operators and security operators, compliance operators, all of the different DevSecOps roles that we talk about. Application engineers can, as much as possible, focus on their applications, but there's also SRE concerns, and there's also provisioning and managing the data services that are used by those applications, right? So each of these areas has their expertise. And again, the emphasis should be on how to effectively collaborate across these roles. So when we say, what should your platform do for you? This question is posed as if it's from the perspective of the application developer, but it's just as important to think about what this means for the platform team that is supporting that. Okay, so the first thing, we're going to talk through 5 different things that your platform should do for you. One is that the platform should be treated like a product. And what we mean by this is that, going back to the old world, as opposed to having to have these indirect interactions with IT operations, raise a ticket, wait for your response, the platform itself should provide a self-service experience that you want to use, right? It shouldn't be a mandate in your organization that you use this platform. If done right, the internal team in the organization that's supporting the platform should be treating you as an application developer as if you're a customer. And you have other options, right? You could do DIY, build the whole thing yourself. They should be treating it as something that competes with that, right? But you want to create the best possible experience. So what this can do is, if not fully treated as a product, then your platform engineer is still in this role of being interacting with every individual role. Everyone's asking the platform engineer, I need this new service on this public cloud that we didn't have available to us before. I need to be able to bind my application to that. Can you please add it to the platform? And now they're back in this role where, in addition to actually managing the platform and keeping it running, they're also having to play this role and decide which team is prioritized over which other team. So the best way to address that is to formally introduce a product manager who actually represents the platform team and handles that prioritization and treats the application teams as customers. And this way, not only do you prioritize the right roles, but you also have more consistency in what's produced. And you have a team that is maintaining that as if it's a product and has existing users. Because if we flip back to the sort of Wild West DevOps approach, then individual application teams, they may be sharing something that they think of as the platform. And one application team needs it to do something, so they add that thing. They write their scripts. It's all working. They go back to building their applications, and they basically added this thing to the platform, but they don't maintain it. Another team comes along, they want something that's similar, but not quite. So they either add something new that's duplicative and also not maintained, or they tweak that existing thing in some way that works better for them. And maybe that breaks the other team that's been relying on it for months, right? So all of this can happen if you don't have a more formal structure and recognize that the platform is something that needs to be maintained as a product with a team. Ideally, that's a small team compared to all of your application teams. Like, it's a very low ratio of platform engineer to application team, especially once you get beyond the initial stages of setting up what all of your teams need. So again, it's about collaboration. It's about creating a optimal experience that the application teams want to use, so it doesn't require a mandate, and having a product manager that prioritizes that, and a team that actually maintains it as a product. The next thing that we want an application platform to do is to shift outcomes left without shifting the burden left. And so what do we mean by this? Well, if we think about the typical view, I think in a lot of cases of a platform today, platform is viewed as the target runtime where eventually your application lands after it goes through a whole build pipeline, right? And if that's the way that you view the platform, then what ends up happening is you have the security operators, the network operators set up things like requirements at the platform level everything must be MTLS encrypted. Maybe applications can't be deployed unless they've been, you're meeting certain SALSA guidelines. You have SBOMs, and those have signed attestations. All of these requirements that you might have as gates to the platform are going to be causing a problem for application developers if they don't know about those things, right? So they need to know up front so that they can adjust their build pipeline and make sure that they are generating that SBOM and they are signing that, and they're going to be able to pass those gates at the platform level. So the best way to do this is to actually, and this can become overwhelming for the developer when you consider this is not just about security and compliance. It's also about following certain guidelines from the enterprise architecture team, or making sure that you're using only these curated data services that the platform supports, and so on. So one way to solve this is to really kind of think of shifting the entire platform to the left, right? So that the platform ends up meeting the developer closer to where they are, right? They should be able to submit their code and have the entire build pipeline be part of the platform. And this way, things can be enforced earlier, but the enforcement can be in the sense of notification, right? But not blocking or not delaying the developer, because you don't want the developers to, every time they grab a package and it has a new vulnerability, you don't want them to have to stop their work because it was scanned right away, and that vulnerability won't make it into the production system, right? Because if they have to stop and adjust their dependencies to deal with this particular vulnerability, then it interrupts the flow of their development. But if they get a warning that this particular dependency will not make it into production, they can deal with it when the time is right. So it's kind of like test-driven development in that sense. You get early feedback while the context is in your mind. Sometimes it might be as simple as bumping to the latest version of that dependency, but in other cases, it might be that vulnerability is a false positive, and what you really need is to create a VEX document that describes how you've triaged that and show that it's not exploitable. So doing that when the time is right is one of the ideas. So we want to shift left the awareness, but not necessarily shift left that burden. So another part of this is that sometimes I like to say, with the platform providing all of these self-service APIs, if the platform gives you an easy-to-use scanner, it automatically generates your SBOM. It creates signed attestations for the steps in your build process. The more of that that's done by the platform, the less the developer has to manage it. So I think of it sometimes as shifting right into the platform in order to shift left from the developer's perspective. Okay, so the third thing that a platform should do for you as a developer is to provide paved paths. And we talk about paved paths quite a bit, but what does it really mean? Well, it kind of follows along from what I was just saying about the platform providing support for these things. So there are all these tools out there that it can be overwhelming for a developer when you look at the CNCF, eye chart diagram. There's many different scanners. There's many ways that you can satisfy the needs of the platform's requirements using those tools, but you have to assemble them together to make that happen. And really the biggest thing, even if you have all these tools, even if you have, you can handle more generic things like scanning source code, you need to build a container image, and you might be using Docker build directly. You might be using build packs, right? If you're using build packs, the build is different for Java than it is for Go. But if you have the right build packs installed, that system can auto detect what build pack needs to be used for your code. That can be automated. Where things become harder to just manage in the platform level itself is all of the configuration around that application. So we're targeting Kubernetes. We're going to have a container in a pod. We need health probes to be set on that. We need the liveness probe to be set. We need to bind to the data service that we need and have that injected in a volume mount. We need to connect to some config map that gives us, Spring Cloud config values. We need to bind to an ingress or to an API gateway, add a route, right? So all of these things are part of going to the production environment, and that can be a lot of work for the developers. When a second team comes along, a lot of that work is going to be duplicated, right? Especially if you have multiple teams, they're all building Spring web applications, They're all using Spring Cloud Gateway. So there's a similar shape to these applications. You don't want multiple application teams to come along and reinvent the wheel each time. And so as this expands, the trade-off becomes pretty obvious that the more you can standardize, the better, right? If you can create a reusable paved path, then all of these teams can make use of it, and you have improved consistency, and you're allowing your developers to be more efficient. So one more piece of this, though, is that this allows us to deploy, if done right, this paved path can also include things like I mentioned. We're building Spring Web Apps. Everyone uses Spring Cloud Gateway. We need to create the HTTP routes that bind to that gateway. And if we do that the same way every time, then it's consistent. And what this also means is that the development team can actually focus on individual microservices as opposed to having to deploy the kind of distributed monolith. And so each individual microservice can be deployed independently, because part of this paved path is adding the binding to a shared service that's already there in the platform. So you don't need to configure the gateway, you just need to configure the route. And configuring the route is just a matter of filling in the right values that land in the template. So there's a lot of templating of resources defined as YAML for Kubernetes in these pipelines. Now, likewise, teams probably create their own way to promote their application from staging to prod, and that's another thing that you can standardize on for consistency, but also for efficiency purposes. Now, this can go too far, right? So you end up with a single opinionated experience, and that's the only way you can get applications onto the platform, or you really only support Spring Web applications because that's what's expected in this build pipeline. You might have another team that's building machine learning applications. You might have another team that's building Go applications, right? So it's better to have the ability to create more than one paved path, but you don't have to have one paved path per team, right? So like the idea would be you have 100 teams, you maybe have 3 paved paths, and 80% of your teams are Spring apps and they're using that one paved path, but the 20% of other teams are using a couple of others. So we look at this from the platform perspective as being, classes of applications that can have their own configuration. And it's all about achieving that balance between what's specific and what's common. Okay, so the fourth thing that a development platform should do for application teams is to provide as much out-of-the-box support as possible for the various runtime services and the business's opinions, right? So that you can meet the guidelines, but also have consistency for all of the applications you're deploying. And so developers are probably happiest when they're in their inner loop and they're building their application and running it on their laptop, right? This is when everything's going well. You can rely on maybe an in-memory database. Maybe you're using test containers or Docker Compose, right? But there's the fewest moving parts in this world, and therefore it's easiest to achieve that flow state. But as you take that application and you're not going to be deploying it on your laptop, so deployment for production might mean moving to a data center, right? And in that data center, you have a database, you have an API gateway. So there's more configuration, like we were just talking about with the paved paths. There's more configuration around the edges of your application to bind to these things. But the platform could provide as much of that as possible, right? Like every team shouldn't have to bring their API gateway, shouldn't necessarily need to bring a database. If they can specify, I need Postgres, and I know that the platform will give me a Postgres. So these are the things that can be brought by the platform. However, as the application developer then moves on to, we're now going to be targeting a Kubernetes-based environment, inevitably, they have to start learning more about Kubernetes. They have to be able to define that YAML for the custom resources that will allow them to deploy these things into a Kubernetes-based environment. And they might also be configuring things like data services on the cloud, like RDS, instead of a self-managed database. They might be configuring the networking for a global load balancer that sits in front of that API gateway. So it's more and more stuff that this application developer needs to learn. And what's happening is they're actually starting to focus more and more on the infrastructures. Now you tell the application developer that this application needs to be highly available across multiple regions. And now they have to learn about where those regions are, how to configure for them, how to set up the networking to work across them. They need to think about the latency for different customers that might be closer to one region or another. They need to think about the data that they're sharing across these regions, right? And how to configure that. And I mean, that gets into things like, is this an active-passive configuration, or more likely it's active-active? And there are a lot of concerns there that affect the application developer. So again, there's a lot to think about. This might also involve sovereign cloud. The application developer might be responsible for generating the dashboards for observability of their applications, right? Like, they definitely need to be thinking about what metrics they're going to emit, and maybe thinking about it from the open telemetry perspective. But should every application team also be responsible for managing the underlying infrastructure, for collecting those metrics and displaying those metrics? The more that could be baked into a platform, the better it would be for application teams. Cost optimization is another concern. There's a lot of tools now in the FinOps space, right, where you can have an application that moves from one region to another, or maybe you have a low priority application that can run at certain times of day based on cost, and you can actually configure that into the automation of the application. It's another thing that could become a requirement for the application team to focus on, and not only one application team, but a dozen application teams that all are told that they need to address this on their own. And then A/B testing, the list goes on, right? Ultimately, it leads to just this extreme cognitive load on the application developer. So that as much as possible, if these things can be baked into the platform and they can be managed by those roles who have the expertise in dealing with them, then they can be reused across multiple application teams, and the application developers on those teams can focus on declaring the intent for their application, right? They could have an application and they know that it needs to run on these 3 regions, right? They should be able to specify that, but have the platform be smart enough to automate that deployment across those 3 regions. Okay, and then the last one here is to have a developer portal. And the idea is that even if you take away all of those infrastructure concerns that we've been talking about, and the developers are truly able to focus on their application, there's still a lot that they have to deal with in the world today, right? They have to know where their source repositories are. They have to know how they're managing that. Is it, what style of the development are they using? Or is it certain branches that are being automatically deployed in a continuous delivery model? What metrics do they need to focus on for their application, and where can they see their application running as soon as it's deployed? They need to know about the CI/CD pipelines. Obviously, they need to be able to check on the build status of their applications. They need to be able to see things like the results of vulnerability scans and any workloads that are affected when there's a new vulnerability available or that's recognized. If they're building, especially if they're building microservice-based applications, they need to collaborate with other teams. They need to find those teams' APIs. They need to get the Swagger doc for those APIs, maybe generate mocks to use those APIs, to start testing against those APIs, and so on. And so all of these things in a typical world, an application developer needs to either have all of these tools that they know that they go to every day, and there are a bunch of bookmarks for those in their browser, and they have Slack, and they go to the right channel to ask questions about, where's the API documentation for this particular project. And it all depends on who you know. You ask someone who you think is on this team, but they're no longer on that team, and they forward you to someone else, and then you find that information. So all of this can become overwhelming also, especially in a large organization. And bringing it into a portal means that you have a single pane of glass where you can basically have the dashboard for the things that matter to you as an application developer in your day-to-day work. And what this doesn't mean is that you copy everything and bring it all into a single centralized managed place. It's really acting as this first pane of glass that will give you 20% visibility across everything, and 80% of the time that's all you need. But when you do need to dive in, you need to see there's something going on with my application, then it should be able to link you out to a Datadog or whatever tool you're using for getting that next level of information, right? It should send you to the Git repository where your application is running. But things like documentation for APIs can be part of the catalog in the portal. And that might provide contact info for the team, might link to an internal wiki, or might link to an internal Slack channel where you would go for the next level of information, but at least brings it all together so that you have that as a developer. And Backstage is really the open source project started by Spotify that really addresses this. That's become extremely popular, and it's what we build the developer portal on for Tanzu as well. It has a plugin based model, and there are a lot of community contributions for those plugins for everything from CI/CD pipelines to different observability tools. There's an API docs plugin that's built so you can browse and discover. So it's a really as we're on this theme of the platform should be all about collaboration. It's definitely the main focus in the portal as well. And if you read the blog posts that Spotify wrote when they decided to create Backstage, or what became Backstage, that they initially created internally for their own use, it was solving exactly this problem, right? A team needs to build, or a team needs X, so they go build X. And it turns out that this other team already built X, but they didn't even know about it, right? So like discovering these things, being able to find the information once they do know it exists and be more efficient, it really worked for them, and I think it works for a lot of large organizations. Okay, so that pretty much brings us to the end of the presentation. What should you expect from an application developer platform? Again, you want it to be treated like a product. You want it to be maintained like a product. Application teams might want to tweak it and add something, right? But adding that thing to the product, perhaps there's an inner source model, right? So you're still able to contribute, but the product has a product manager and is treated like a true product that competes with whatever else you could be using, so that your team isn't given a mandate to use it, but actually wants to use it. And that obviously will create a better experience for everyone. Shifting the outcomes left is really about having awareness earlier in the process. Here's a code, here's some code that was scanned, and I know there's a vulnerability as soon as possible, not when the admission controller in my Kubernetes cluster verifies against the SBOM, right? So like having the tools that make that possible be part of the platform and meeting the developers where they are, but also not creating a situation where they have to drop everything as soon as they find out about something in their system. Because it might be fine to continue developing for a little while, that they know I'm not going to be able to get to production until I address this. They put it on the list and they address it when they can. Paved paths, again, having consistency, being able to create, I refer to it as micro platforms, right? It could be a single platform that does provide multiple paved paths, but the smaller the number of those, the better for consistency perspective and for manageability from the teams that use them. But you could have micro platforms, right? You could have a very focused Spring experience through people using this paved path, and a very focused machine learning experience for people using this other paved path. And they can come together and use the same platform and still share underlying infrastructure and underlying data services and the network and so on. But having these different flavors that can surface on the platform. And then, of course, runtime services and opinions. This is, again, where if you look at the CNCF eye chart diagram, there are 100 ways to do anything. And if you just leave it up to the application developer teams, you'll probably end up with 50 of those in your organization. So this is an opportunity from the platform team's perspective to curate the services that you want teams to use. Create enough that there's variety that meets their needs, and accept requests, right, to add a new service when a particular team really needs it. But otherwise, this also helps increase consistency. And if a developer is moving from one team to another team, it will also be easier for them to get up and running on this new team if more of the services that are used and the configuration that's used to bind to those services is common, right? So having those opinions baked into the platform is useful. And then finally, the developer portal and what that enables for developers to be able to quickly find what they need and also to collaborate with other teams. And with that, that brings me to the end. So thank you.